My name is Peter Lammersma and I am a Uniface software developer. In the next 20 minutes, I want to explain you what JSON Webtokens are, where do you need them for, why you need them in 2021, and how you can use them in Uniface. A small spoiler again already, JWT token is about trust. It's about the validity of information that you share between another system. It can be anything, but it's mostly used for authentication. So authentication between a client and a server, for instance. Thus is the person sending this JWT the person he is claiming to be. I want to make a real-life example, and that is a bank card. Let's say you go to a foreign country, to a city you've never been before, and you're hungry, you want to buy something to eat, so you go to a shop, and you can buy everything you want with your bank card. That's strange, isn't it? Does the shop owner trust you? No, not by definition. He or she will trust the bank card you're showing, because the bank card is an evidence of trust, of your identity. That's because you went to a bank first, you identified yourself, you opened a bank account, you put some money on your account, and they gave you this bank card. And with the bank card you can pay everywhere in the world. You go to an ATM and get cash out of the wall. But it's just a piece of plastic. A bank card is a piece of plastic. And why is there trust in this piece of plastic? That's because the bank added some enhancements. They added something to say who they are, who gave you this card, who you are, and they added some stuff to make it secure. But what about the virtual life? You go to a website, you have an account there, and you have to identify yourself. You need to prove your identity, but how? Well, we all know you go to a website, the website shows you a pop-up, you fill in your credentials, username or password, and that's being checked on the server, and you're done. And you can use the website without having to provide these credentials every time. And that's strange, because you know that a website, a web page is stateless. So it's like visiting the shop, the real life shop, every time again. For everything you want to buy, you go back and forth from the shop. In a website, that's being solved by a session ID. The session ID is something that is being calculated by the server, and it depends on the TCP connection. So in the handshake between the client and the server, this session ID is created and it is stored on the server. So as long as you use the same TCP connection and you're within a certain expiry period, 15 minutes for instance, you can use the session ID to prove your identity, because it is stored on the server and you show it on every visit that you have to this website. But it has a few drawbacks, and let's assume you go to you want to use identity provider. You don't want to use a username or password, but you want to use your Facebook account or Apple ID to prove your identity. You can't use a session ID there, because the authentication is done by another application, another server. Or you want to use multiple devices or different clients. You want to use Team or Zoom on both your phone and your notebook, for instance, at the same time, but you're still the same person. You can't use a session ID there. Or you have multiple users, or you want to resume a session. You want to close your laptop when you go home, and the next morning when you open it again, you want to work in the same session. You can't do that with the session ID, because this TCP connection is expired. Even more interesting is on the server side. You can have on a server, you can have different or several VPSs, several servers, or Dockers, for instance. Applications are spread over multiple machines. You can't use a session ID there because that was determined in the determined between the client and the server. So, but when you have several servers, how do you do that? Or you have multiple applications. My bank has a online banking website, but I can also go to at the same time without reconnecting, without having to provide my credentials again. I can watch my credit card balance or my insurances. There are different applications, but for me it is just one application, a kind of single sign-on, but I know there are different applications. And in the future you will have microservices. So applications consist of smaller parts of other applications glued together, like the identity provider in the top left. It is an example of a microservice. It's like using your bank card, having a bank card that is valid for only one day and you can use it in one shop. We don't want that, so we need to have another solution. We need to have an online solution that is nearly the same as the bank card process. But instead of going to a bank, we go to identity provider. We will provide whatever we need, our Apple ID or our Microsoft ID, and that identity provider is a trusted party, and they give a JWT token, and with that token I can prove my identity in a website. So it looks nearly the same as the banking example. So when we put these two next to each other, on the left the session ID and on the right the JWT process in an online world, they are nearly the same. The major difference is that the session ID was stored on a server and JWT is stored on the client. That makes the process between client and server independent of the TCP connection. This JWT process looks like the bank card process. It's about trust. Bank added some stuff, enhancements to this bank card to make it trustworthy. We can do the same with a token. In the token that's called claims. And claims are the elements that are added, and you can use them to claim something, who you are, how long it is valid. And it's the same as the visible parts of the bank card. But now we store it we create a JSON from it, because it's JSON Webtoken, of course. So this is the nerdy part, and JSON we can create, of course, with Uniface. I think we've all done that. It's very easy. The visible parts of the credit card are the claims in what we call the payload of the token. So we have the issued at, expires on. We can have a subject. We can specify the issuer, and we can add many more. But some are reserved claims. So you need them. If you use them, they have the meaning that they have by definition in the standards. But there are a few issues. Of course, we can create this JSON. That is not a problem in Uniface. But there are some issues with how we create it. How do we send it over the line, and what do we put into this claims? I'm going to solve these issues, and they have something to do with date and time, the HTTP header, and of course the security, because security is most important, I guess. Let's go to the time-related issues. When I created this presentation, I created this payload. It was on October 3, 14:52 in the afternoon in the Netherlands, and it expires 2 hours later on 16:50 2 in the afternoon in the Netherlands. At the same time in Australia, it's 9 hours later. So the token was already expired there. At the same moment in LA, it's 5:52 in the morning. The token wasn't even valid there. It wasn't even issued at that time. We all know that it doesn't work this way, of course, but that's why you and I communicate like humans, and then it all makes sense. But JWT tokens are created for communication between systems. And it's about trust, so you can't guess, you need to make sure. So that's why we need to specify the time zone. Working with time zones can be done in Uniface, since Uniface 9.4. And adding a time zone can fix this problem. So we can use the UTC time. We need to add the offset of the UTC time to the data time that we're specifying. For the Netherlands, that is +2 because it was summertime. Now it's +1 because now it's winter here. That will result in a time that can be compared with other time zones. That is the issue, I guess. But still we have another problem. That is, how do we communicate the time itself? So not what the time is meaning, but the time itself, the format of the time. There are dozens of standards. There are thousand ways to format, to lay out a date and a time, and it depends on my language, my location, the standard I'm using. You can use ISO 8601, but even that has different ways to have the layout of your date and time. So that's why we must use, that's by definition, the Unix timestamp. And Unix timestamp, also called the epoch time, is the number of seconds elapsed since January 1st in 1970. So we can calculate that. It's about 1 billion and a lot more. It is stored in a 22-bit integer. And that will have a small problem in future. That's called the apocalypse. I am maybe the first one to warn you about this, the apocalypse. That is in 2038. Then we will have an integer overflow of the epoch time. So then we have a problem. Kind of year 2000 problem, but then 2038. I'm the first one to warn you. So how can we do this all in Uniface? Working with Uniface can be done since Uniface 9.4. By definition or by default, it is switched off, and you can turn it on if you want to use it. Documentation is very good about it. But Uniface can't calculate the epoch time, and I found it very hard to calculate or to determine the offset of the time zone, for instance. So I have created a couple of functions and a few test forms, and I will share them with you on GitLab. More on that at the end of the presentation. So date and time can be fixed, but now what about the HTTP header? The token must be a very long string in order to send it as a parameter in the HTTP header. So it can't have carriage returns, and it can't have certain characters that have a special meaning in the URL or the HTTP protocol. We need to eliminate them, and that can be done by using base64 encoding. That's default Uniface base64 encoding. But even the base64 encoding can have a couple of characters that are not allowed in the HTTP header. So that's why we need to use the base64 URL encoding. And that is a very small enhancement of the base64 encoding, and I have created a function for that too that will be shared on GitLab as well. So that is not a problem anymore, the HTTP header. That brings me to the last part of this presentation, that is security. So one small recap, the payload is on the left, in the left border. We fixed the datetime issue, that gives us the payload on the right. And to fix this HTTP header issue, we use this base64 URL encoding, and that gives us this long string in the solid green box. But remember, it is encoded and not encrypted, so you can decode it and have your payload back in a readable format. So never ever store anything confidential in the payload. It can be read, it can be modified, because it's already encoded. It's like writing your name on a bank card and try to use it in a shop. You don't have to know anything about security, but the shop owner, I think he will see that you modified the card. We can use that same kind of trust in the token process. So we need to add something so that the person who is, or the system that is receiving this token can see whether or not it is modified. So we start with this payload, number one, payload. Did some base64 encoding that gave us the solid green box. Number two, nothing new. Now we need to add a signature, and the signature is a encoded hash represent the validity of the payload. Is it changed or is it not changed? You can use several algorithms for that. Uniface supports, I think, all algorithms that can be used, but you need to specify it in the token so that the receiver knows which protocol you have used for creating the signature. So you need to add that to the token as well. That gives a header. So the token will contain two parts, a header and the payload. The header is for the signature creation, and the payload is for the information you are trying to send. And both will be hashed with a encryption protocol, and that will result in a total payload of the complete token. So the complete token contains the three parts: the header, the blue part, the green part is the payload, and the signature is the purple part, separated by a dot. And you can modify it. You can modify it whatever you want, but then the signature is not correct, and so the receiver will see that it is modified. So and a modified signature, or the modified token, is not valid. Easy. Can this be done with Uniface? Yes, but you can use all encoding and all decoding, encryption, decryption. You can work with JSON, no problem. The rest is just functionality, creating a token, validating a token, verifying it. I have built a few functions. I will share them also on GitLab, and it includes a few test forms so you can see what you're doing and how it all works together. So on GitLab we have, I will share 25 functions, few test forms under an Apache license, so you can use it for free and you can modify it. You can enhance it, and please put it back what you have changed, so we can all learn from it and all use it. More information can be found on the website of my company, univisuals.com. There you'll find not only information but also the links to the GitLab process, or the GitLab project. Hopefully you know that trust is good, but knowing for sure is better. The shop owner doesn't trust you, but he will trust your bank card. a website doesn't trust you as a user, but it will trust your web token. So a very small recap. Hopefully you know what JSON Webtoken is and why you need it, and that you're sure that it can be done in Uniface. You can create it all by yourself in Uniface. It can be done. It's just functionality. Uniface provides everything that you need. But to make life more easy, I have created a couple of libraries and functions and test forms, and I will share them on my website, univisuals.com. Finally, all the information about JSON Webtokens can be found on the website jwt.io. That is the website of the founders of JWT. And remember, never ever store anything confidential in your web token. Thank you.